Hello, everyone. It's me, Mr. Younger, again. Today is Tuesday, March 18th, and we're doing another lab. This is actually lab 8, and it's a projectile motion lab. This one we do the projectile motion lab using a altered document instead of using the original document that we wrote for projectile motion in class, like we normally do, and then add an addendum. In this case, we actually just made a document that's already up to speed and includes the PHET process as opposed to just you filling in from the addendum the important information to help you fill out the rest of the lab report. This lab report's ready to roll right as it is. Again, it's on Projectile Motion. It's on the PHET website, and I'm now going to go ahead and share my screen with you so that so that I can explain how you're going to go through doing this lab. It's not really that hard, but if you don't follow instructions and don't really read carefully, you can make some really big, easy mistakes. So, hopefully, my intro will help you out, and I'm going to go ahead and share the screen now. Looks like it's that one. Okay, so first off, you'll see there is a new week, week 9, from March 18th to March 24th. Remember, the lab is technically due Tuesday at 11:59 p.m. This date, the 24th, is technically Monday, so it's really that your lab is due on the 25th at 11:59 p.m. That gives you the full week, and it gives you plus the entire day today, or the day Tuesday, a week from today. It gives you that whole day till 11:59 to turn it in. You can see this is the actual document. Notice it says PHET. The fall 2020 is just when we first made it. We correct it and fix typos and often never even change the name. So it actually has been altered since that 2020, but not hugely. This is where you ultimately turn it in. You'll see in there it's got the typical generic instructions of how to make a lab report from this class, which remember includes you turning in the entire document that I give you, which is the Word document I was just looking at, and making sure all the font that you put into the text by typing is not black. Okay, you got to make sure you do that just so it's easier for me to pick out what you added versus what was already in the lab report. So I'm going to go back to the module now again. This is the actual lab we're talking about. That's where it turns in. I'm going to flip to another page where I have the actual lab document loaded. And what I want you to see is it starts off telling you getting rid of all the stuff that we really didn't need because this is all the stuff we'd use in the face-to-face lab. But you will need a computer, Excel spreadsheet, access to the PHET website, and potentially the need to download and run an HTML file. So ideally what's going to happen is you'll read this instruction and click on here and it'll automatically open up another tab or another window depending on your browser settings, and you can hit run or you can hit play and stuff like that immediately. However, if you find that you can't hit play when you're there, that's probably because your browser permissions aren't set up properly to run uh, 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 an application like this over the internet. It actually wants you to install it. So if you do that, it tells you specifically here, if the play button does not work, then click on the download at the bottom left of the projectile picture, and then open the file when it appears on your screen or in your download folder, and then click on intro. So that way it'll be running it locally on your computer as opposed to doing it over the web, which could, put your whole computer at risk when you're doing something like that over the web. So some people just don't have theirs set up that way. This site is trustworthy. I've never known any problems with it. It's set up by the University of Colorado, if I remember correctly. I think it's University of Colorado at Boulder, but and I might be misremembering that, but that's what I recalled. Anyways, it gives you step-by-step instructions what to do. It tells you like what speed to leave it, so you'll be able to slide this lever back and forth, for instance, to change the speeds that you're firing. You can also adjust the angles, that sort of thing. But the parts that students usually don't get in this lab are in the face-to-face one. That's why I'm focusing on this right now. They don't necessarily get what goes on here. So what's supposed to happen is you're supposed to, using these numbers, 1.20, 1.40, and 2.83, you're supposed to be able to set up a Excel spreadsheet just like this one. And then these numbers that aren't, I think all of them except maybe the first two zeros or whatever, all of these are going to pop into the field once you've got it set up correctly. So they gave you some very specific advice. Make a spreadsheet as illustrated below, which will calculate the predicted value of x for each angle from 0 to 45 degrees. They did tell you to consider down to be positive so that the x, y, a, and v sub y will be positive. Only the v0y will be negative. And then in A1 and A2 are sample data. A3 is computed from the values of x and y and x at 0 degrees, which is something you will do later when you actually try yours. Uh, the column entitled Angle in Degrees will list the angles from 0 to 45 increments. Increments of 5 degrees. Column B through E will contain formulas. The numbers that appear in the spreadsheet below in the column B through E are those that would be computed using the sample numbers in A1 and A2. So these two numbers, of course, this one would be determined, of course, but these two numbers make all of this happen if you've got your spreadsheet set up correctly. So before you run any kind of data and stuff like that, you want to put these numbers in and then make up your spreadsheet. Make sure that with these specifically two numbers, all these numbers fill in exactly as this is. You might even carry extra digits if you want, that's fine, but make sure it's at least accurate to three decimal places as showed in this column and this column, but to two decimal places in this column. Okay, so that's probably the one part that's a little confusing to students, and you can see it's a not necessarily a very long paragraph. If anybody's ever read, for instance, Dickens, it's not that long of a paragraph, but still, it's a wordy paragraph, and it's one that students don't always have a good experience trying to read. So do your best, read through it, make sure you can make this up. Once you can do this, then you can continue with the experiment, plugging in your own values of y and x and your own muzzle velocity, and then it will spit out the correct values. So just follow these steps as they are, and everything will work fine. Here's all the formulas that they're using. Remember to use your dollar symbols when you need to, but that's basically it. It's a pretty straightforward lab, and you get to work on your ability to solve projectile motion problems. Again, in these online labs, we're not stressing as much experimental work and discipline and practices because we can't. Online we can't really fulfill that sort of lab yet unless we start doing other things, send out packages of equipment or computers or stuff like that. So it's a little more complicated to fill it, but that's also why some colleges won't necessarily take an online lab course as to count for their lab course. But still, there's a need for this course, so it's here. Hopefully, in the future, we might actually have something using Raspberry Pi or Arduino and some various sensors as well as your cell phone, assuming everybody has access to a smartphone. That will hopefully or eventually fill the bill on experimental courses for Physics 201, 241, 202, and 242, and hopefully 100 as well. So anyways, as all you have to do is complete this and then fill in everything. Make sure you turn in your lab report by 11:59 a week from today, which, as I said, would be on the 25th. And I think that about does it. Again, this time, noon, every Tuesday that we have classes, noon, I will be on here for an office hour in case anybody wants it, but also for this introduction lab. Remember, normally the intro to lab takes on the order of 20 to 30 minutes, and then at the 30-minute mark, that's when it's a good time for you to go ahead and log in just in case you do need help. So I've waited here. It's now 12:30. It is now 12:30. I'm going to wait here for another 10 or 15 minutes. I'm going to suspend the recording unless someone comes on. Uh, but I'll just leave it right here, and you should be able to use this video to do your lab to get it started. And so on. So have a good day, everyone. Unless I see you again from a student coming in for help, then this will be the end of the video.